We're going to continue with class example 1.8.1. It gets a little bit more complicated though, as we are entering into a few more negative signs here with a few more different variables. So x to the power of negative 3 multiplied by x to the power of negative 5, all raised to the power of negative 2. We have some options here as usual. In our previous couple of questions that we did, I left the brackets and applied only what's on the inside first. We can continue to do that if you like. I also tended to get rid of the negatives first, but we've got a lot of negatives going on here. So why don't we keep the negative 2 for just a moment and take x to the power of negative 3 multiplied by x to the power of negative 5 and remind ourselves that if we've got two exponents with the same base, we get to add our exponents. So I've got negative 3 plus negative 5 becomes negative 8. I'm just adding those together. We know that when we raise a power to a further power, we actually get to multiply those two together. So I'm going to apply now that negative 2. And I've got negative 8 multiplied by negative 2. And in fact, our negatives are going to cancel each other out here. And I get 8 multiplied by 2 is 16. And so in this question, we didn't have to move anything to the numerator, anything to the denominator. If we dealt with just the exponent laws like we did when we were in Math 9, they actually canceled it out, which was kind of nice. Okay, we've got a cubed, b to the power of 4, c to the power of negative 2, all divided by a squared, b to the power of negative 3, c to the power of negative 4. So I think what I'm going to do this time is I'm going to combine the a's and then the b's and then the c's. So if I've got a cubed, and I'm dividing that, I'm just going to write this off to the side, a cubed divided by a squared, I know that that is the same thing as taking the same exponent, the base with the same exponent, and I'm going to subtract the two exponents themselves. 3 minus 2 is 1. I'm left with just an a raised to the power of a positive 1. Okay. We've also got b to the power of 4 divided by b to the power of negative 3. Now, same thing, I've got an exponents here with the same base, so I get to subtract the exponents. Now, let's be reminded that that is the same thing as 4 minus negative 3. And hopefully we remind ourselves that when I minus a negative, it turns into plus a positive. So this actually becomes 4 plus 3, and that becomes b to the power of 7. Kind of makes sense when you think about it. If I look at this one more step further, if I applied the negative of that denominator with the negative 3, b to the power of 4 doesn't have a negative, so it stays where it is on the numerator. On the denominator was b to the power of negative 3. We know that that negative sign in front of the 3 indicates that it's going to swap from the denominator into the numerator. And now I have nothing in the denominator anymore. You could put a 1 if you like. And then I know that if I have two bases, here I get to add, two exponents with the same base, I get to add those exponents, which is 4 plus 3, and that got us to the 7 as well. So we actually have two different ways that we can get to the same answer, but it is b to the power of positive 7. So far with our a's, we have a to the power of positive 1, so that's going to stay on the numerator. We've got b to the power of positive 7. So now let's just take a look at our c's. We have c to the power of negative 2 divided by c to the power of negative 4. Now we also know we're going to subtract those exponents, so that becomes negative 2 minus negative 4. We also know that when we minus a negative, it turns into plus a positive. So we've got c to the power of negative 2 add 4, which actually becomes c to the power of positive 2. So I can see that that positive 2 can actually stay on the numerator there. And we could rewrite it like we did with the b's and move the c squared to the bottom and c to the power of 4 at the top, right? If I'm just taking the negative signs, I can swap those two, and I can see that I still get that whole idea of 4 minus 2, which is the same thing as negative 2 plus 4, so we get there either way. Okay. Negative 3 over 2 all raised to the power of negative 4 and then raised to a further power of positive 2. There's negatives, there's fractions, there's double exponents. This is a lot. First thing I want to point out is how we write a term with a negative. Negative 3 over 2 could also be written as negative 3 over 2 or it could also be written as 3 over negative 2. As long as there's only one negative sign per expression, these all mean exactly the same thing. Okay. Now, why does that happen? Because technically that negative sign out in front is something like a negative 1 multiplied by positive 3 over 2. And we could then say negative 1 multiplied by 3 is negative 3 over 2, and that's how we can put it on the top. If we wanted to figure out why we could put it on the denominator, let's just remind ourselves that anything over 1 is itself. And I know negative 1 divided by 1 is the same thing as 1 divided by negative 1. So I could, change that to multiplied by 3 over 2. Say 1 times 3 is 3, and negative 1 times 2 is negative 2. And that's how we can put that onto the denominator. Okay, so I point that out only because I want to make sure that when we actually apply our exponent at the end of the day, we're not forgetting to apply that exponent to the negative sign as well, because it is also on the inside of that bracket. So I'll keep that up there. And now let's look at this. I've got negative 3 over 2. And I'm going to raise the power to a further power first. Now we know we just multiplied these two together, so negative 4 times 2 is negative 8. Okay, next thing I'm going to do is I'm actually going to apply the negative sign on the exponent. Not the negative sign on the inside. Please don't forget that that has nothing to do with it. The negative sign on the exponent simply indicates that we are going to change the numerator and the denominator, or swap the numerator and the denominator. So I'm going to again keep that negative sign out front. I'm going to swap the numerator and the denominator, and now I can write that with a nice positive 2 exponent. Now, however you want to look at this, it's up to you. Again, we said this time we could write it as negative 2 over 3, all raised to the power of 8. Okay, which means I'm going to take negative 2, the whole thing, and raise it to the power of 8, and 3 to the power of 8. If I do that, I'm going to get negative 2 to the power of 8 turns into a positive number that turns into 256. And 3 to the power of 8 happens to equal to 6,561. So, although it looked really complicated at the beginning, it turns out to be not a terrible number at the end. Now, we could also have left it here. So I'm just going to highlight that as well. Usually when we have numbers on the inside of the brackets versus variables like x or a or b or c or anything like that, we tend to want to evaluate as well. In this particular case, it says simplify the following expressions. It doesn't necessarily say evaluate, but this is the same number, right? These guys are equivalent to each other. Which one do you like better? I tend to like the 256 over 6,561, but that'll depend whether they want to keep it in exponential form or whether they want us to evaluate it. Okay, we got another big one here. Negative 3 over 2 raised to the power of negative 4, all raised to the power of positive 2. This time we're going to take that expression and we're going to multiply it by negative 3 over 2 raised to the power of 2 raised to the power of cubed. So what I'm going to do first is we are going to deal with the powers raised to further powers first. Okay, so I'm going to keep my negative 3 over 2. I've got negative 4 raised to the power of 2. We already know that that's negative 8. Next thing I'm going to do is I'm going to take negative 3 over 2, and I'm going to raise that to a further power. 2 raised to the power of 3 is going to equal to 2 times 3, which is 6. I can still see I have the same base. So negative 3 over 2 is both the same. Pretend they're x's, pretend they're c's, doesn't matter. And I know that when I multiply two exponents with the same base, I get to add those exponents. So when I take negative 8 and I add 6, I get negative 2. So I get negative 3 over 2. That stays the same. Ooh, that's an ugly 2, sorry. Negative 8 plus 6 is negative 2. Okay, so now we've at least got the two terms simplified down into 1. We still have a negative exponent, so that's not great. So instead, we know that a negative exponent does not change the negative sign. It simply changes the numerator and the denominator's location, so it swaps those two. You could leave the negative sign up top. You could leave the negative sign out front. Remember, we talked about that already. This time I now get to write this with a positive 2 exponent. Now you could leave it like this, but we could also evaluate this. And I can actually rewrite this as 2 squared, which is 4, and negative 3 squared, which is 9. And my final answer, if I chose to evaluate it, would be 4/9. Okay, the last one is a decimal answer. So the evaluation becomes a little bit trickier, although we do have a calculator. Let's get to the simplification first. I see I've got 1.4, 1.4, and 1.4 all as my base. I have 1.4 raised to the power of 3 multiplied by 1.4 raised to the power of 4. So I see when I multiply these two things together, I can actually add those exponents. So I get 1.4 all raised to the power of 7 divided by 1.4 all raised to the power of negative 2. This one here, I know that if I have the same base, which is that 1.4, don't have to put it in brackets, but you're more than welcome to do so. I have 1.4 on top and bottom. I'm going to combine those two exponents. I know that whenever I've got a division in between those two, I get to subtract. So this becomes 1.4 raised to the power of 7. I'm dividing it by, which means I get to subtract the exponents, 1.4 to the power of negative 2. So I'm going to put negative 2. We love when we minus a negative because it turns into plus a positive, and all of a sudden now I actually get 1.4 raised to the power of 7 plus 2, which is 9. And if we chose to evaluate this, instead of leaving it just simplified, I'd have to take out my calculator, and I would get, very ugly number. And so you can see why sometimes we don't evaluate them and we leave them in exponential form as well instead, because this is a number I don't know the end to. So in my particular, in the previous two with 3/2s as our bases, they came out to nice even numbers, but this 1/4, not as much. We could turn that into a fraction because it is a rational number. I just don't know when the pattern is going to start to repeat itself.